Okay. We started with balancing equations, and I said let's continue with balancing equations because when I send it online to some of my students, they cannot do it. You know, they are putting a lot of funny numbers. That means they don't understand the fundamentals. Okay, so let's continue with equation of the balancing equations. Okay, so balancing equation is our topic, but it's still on the atom. Okay, balancing chemical equations. Okay. All right. Now, let's go back to the principle because our last video, I did put some fundamental principle which you apply. But first of all, when you have an reaction like sodium hydroxide plus sulfuric acid, you will get sodium sulfate plus H2O. And we said this type of reaction in which a base reacts with an acid is called neutralization. Okay, very famous reaction in chemistry. Okay, it's called neutralization. Okay, you know the meaning of to neutralize. To neutralize means to. They say they neutralize the terrorist. Okay. They neutralize the terrorists, they neutralize the acid, make it ineffective, okay, disabled. Okay, so here the acid was disabled by the base. Okay, because acids are very corrosive, they have a very high amount of hydrogen ion, that's what make them acidic. Remember, an acid, we are going to do acid and bases, but it's the H plus that make acid. Okay, ion. Okay. So, when a base reacts with an acid, you have a salt and water. This is a basic and very important reaction in chemistry. When a base or an alkali reacts with an acid, you have a salt and water. Now look at the ions here. What type of ion are these called? Do you remember? What type of ions are these called? You guys forget. You guys forget very soon. These are called polyatomic ions. And we have done this, and then the note is on, and I can give you the notes copy again, but you aren't here that day. Okay? Polyatomic ions. How they become minus, and how they become minus or 2 minus, I explained in that note. I give example of oxide ion. Yeah, this is oxide ion, oxygen and hydrogen. It's because oxygen is 2 minus when it become an ion. Okay, oxygen is 2 minus when it become an ion, and hydrogen is 1 plus. So in our mathematics we do, okay, let's say we plus 1. We normally don't put plus 1 there, but we put only plus there. Okay, but we meet plus 1. Now, in the mathematics we do, minus 2 plus 1 will give you minus 1, the sign of the bigger number. That's why an oxide ion is HO minus. So when this reacts with another hydrogen, the positive and the negative neutralize it. So the compound that will be formed will be H2O, that will have 0 charge, and that is our water. Okay? That is our common water. So there will be no charge because 1 minus 1 will be 0. That gives us our water. So all the polyatomic ions, you can do the same thing for all of them. Okay? Nitrite, nitrate, all of them. Okay? Phosphate. Yeah, I think phosphate is 4 minus. Okay? All of them, you can find why the charge is on them. All of them, you can demonstrate why they have an ion like that. Okay. Now I'll allow you to copy the notes and then you study this because it's very important one. If you know this, you can easily know when they ask you, they didn't give you the product. You can easily know what product are home. And when we do metals or even utilization, a more reactive metal displays a less reactive metal. You understand? So sodium will replace hydrogen here. Hydrogen will take that one. Okay? So that one and that one give you the water. You see? So now, where is the duster? When we do balancing equations, this is even better. When we do balancing equations, we have to be careful of these polyatomic ions. Now, what we do is draw a line. You put the ions in the product here. So the reactant, the ones that react are called the reactants, because they react. And this one from here are called the products. Now, the polyatomic ions, SO4, OH, don't touch them. Okay? That's one important thing. If it is SO4 here, you leave SO4. Okay? It's SO4. If it is OH, you leave your OH. Sodium by itself. Hydrogen here by itself. Okay? Don't put the two there. The two what is there, don't put that there. Like it's H2, you put H2 here. No, only H. Because when you are balancing these things, as I said in my last video, you guys have to look, before you write. I said this, we only deal with the coefficients. Okay? We only deal with the coefficient. Coefficient, I said, the number that multiply this. Okay? We only deal with the coefficients. Not the atomic atoms or the molecular atom here we have down here. We don't deal with those ones. We don't take them at all. But what is going to have here, like in mathematics, when you say 2x plus 1, the coefficient of x is 2. So that's what we put numbers here, but not the numbers here we change. The numbers down, like 2, 4, 2, 2. We don't change those ones at all. Okay, we change only what multiply all these things. What you call the coefficients. Okay? Now, from each side, the reactant side and the product side, okay? The reactant side and the product side. Now we look at SO4. Look at the SO4 here. Okay? Now, if we rub this thing off. Let me write this again. Where is the black pen? Okay. You said sodium hydroxide plus sulfuric acid or sulfuric acid will give you sodium sulfate plus H2O. Then a salt and water. When an acid reacts with a base, you have salt and water. Okay? I told you that one you have to memorize those two because they are very important. It's called neutralization. Okay? Now, we have a reactant side, we have the product. The product is water and sodium sulfate. Now, we look at the sulfate ion here. Okay? First of all, let's look at sodium ions here. There's 2 sodium here. 1 sodium here. How many sodium here? 2. So we can say on this side, sodium is 1. Okay? But on this side, sodium is equal to 2. So that means what? We have one more sodium here than here. More sodium on the product side than the reactant side. And there's a law, you remember? What was the law? There's a law which determines this. There's a law called conservation of atoms. Yes, conservation of mass. Okay? Conservation of mass. Or conservation of the atoms, yes? We call law of conservation. You can call it that way. that the atoms cannot be destroyed in the reaction. Okay? The atoms cannot be destroyed in a reaction, or new atoms cannot be created. I explained in my previous video. Okay? So what is the number of atoms on the reactant side must be equal to the number of atoms in the product side. Okay? So therefore, must look here. For hydrogen, we have 2 here. 2 hydrogen. 2 hydrogen. And we have 2 on this side. Okay? 2 hydrogen in it. SO4, we have 1 and 1. Okay? SO4 is 1 and 1 on this side. Okay? Now, we look at OH. OH, that's why it's a polyatomic ion. So you must understand that. Don't look at hydrogen by itself and oxygen by itself. It's OH. Because what happened is sodium ion. Put that there. What is happening here is the sodium ion reacting with OH minus polyatomic ion. This one also is not break, say, sulfur by itself, oxygen by itself, but it is the hydrogen ion which is reacting with the SO4 2 minus. Okay? So 2 minus 2 is 0. So don't break them off, leave them as they are. Do you get it? Now, OH means there's only one OH on this side. Now, the first anomaly, the first discrepancy between the two, because we said there's a law of conservation. You cannot create or destroy the atoms here. The number of atoms on the left-hand side, which is the reactant side, must be equal to the number of atoms on the product side, right-hand side. So if it is 2 here, if it is 1 sodium on this side, we must balance it with another sodium on the other side. So sodium basically, we should make it 2. Cancel the 1, make it 2. Sorry. By making it 2, you multiply the coefficient here by 2, in it. I have to juggle with pencil a lot. I want to make it as clear as possible. So when we put 2 here, so here we have 2 sodium, 2 sodium. Okay? So in our table here, we put 2 sodium now. But if that happens, we have changed the dynamic again. Because instead of having 1 OH, we now have 2 OH in it. Yes. Okay? We have 2 OH. Now, sorry. 2 OH, sorry. OH, we have to leave it like it is O and H. Because there's no O and H on this side, isn't it? Yeah, so we have to look at oxygen and hydrogen. Okay, sorry for that mistake. Now, since we have 2 sodium on that side, that's balance. Now, since we have done that, look at the hydrogen. Now we have 2 times 2, so 2 times 1, 2 hydrogen here, and 2 hydrogen here. I mean, we have how many hydrogen? 4 hydrogen. We have 4 hydrogen, sorry. I mean, 6 hydrogen. 2 and 2. That's 4 in it. So hydrogen was 4.
So it has to be oxygen then hydrogen. Oxygen and hydrogen separate.
Yeah, that's right. Oxygen and hydrogen separate because you don't have another OH in this equation on the other side here. If you have the same thing, you have to leave it like that. Yeah. Now, look at it. Put your mind here, please. Okay. Now, how many hydrogen we have? 4 hydrogen. Now we have to make that 4 in it. Yes. So to make it 4, we have to multiply 2 by 2 in it. Okay. But if you look at our sulfur ion compound, and they are the same. 1 here, 1 there. So that's the balance as at now. Okay. In some other equation, it may change. But as of now, there's 1 sulfur and there's 1 sulfur, so it's balanced. Okay? This was 1 and we cancel it, it becomes 2. Yes. Now, since we have dealt with our sodium and our hydrogen, now we are left with oxygen. Because sulfur and that one is balanced. Now it's oxygen. Now on this side, how many oxygen do we have? Two in it. I said we ignore that one, okay? Because both one, they are all here. So we ignore the oxygen on this sulfate ion, yeah? Two oxygen here. How many oxygen do we have here?
One.
No? Two. 2 times 0, yeah, because 2 is the coefficient of that molecule, yes? Yeah, so it's balanced. So the oxygen on this side is 2, on this side is 2 now. But before it was 1, 1, 1. But because we change the 2 here, it becomes 2. So we have make sure that we balance on the reaction side as well. Okay? This is a very, very simple one. Now let's look at. I sent a very, very difficult one online, yeah. But I'm going to. I'm not going to do that for you. That one after we do more and more examples, then I will. Now let's look at some very, very, very some difficult examples.